Hello everyone, welcome back. So in this video, we are going to understand question number 3. Maximum product of two integers with no common bits. Okay. So if you try as the question is saying that, at that time you get the TLE and the wrong answer. Okay. So what you can do, you have to stick to the approach that I'm going to tell. Okay. And let's understand. Very first, what we have given is, we have given nums we have given, as you can see in the example 1. So we have given an array, nums array, and we have to pick two different indices I and j, because our task, what is our task? Your task is to find the two distinct indices I and j. So it is saying you are given an integer array nums, we have to pick two different indices I and j, so that the product, if you apply the two elements product, that is at nums at I and nums at j, is maximized. Understand? Means the two numbers nums at I and nums at j have no common set bits in their binary form. Okay, so it is saying the binary representation of these two elements do not share the common set bits, we can say. That means the two numbers nums at I and nums at j have no common set bits, we can say, in their binary form. Okay, so nums at I and nums, if we'll take the nums at j, it will give always 0, and so their product nums at I and nums at j is always a larger value. Understand? And that is why we have to return the max value. Are you understanding? So what is the meaning I'm trying to say? Let's suppose we have some element nums at call I, and if we'll take the nums at what, j, so it should always give 0, right? Because if two numbers nums at I and nums at j, if they have no common set bits, right, no common set bits we have, it means what? It should always give 0, and that is why if we'll multiply, its result should be maximized. Guys, if no pair of numbers has disjoint bits, it should always return 0. Okay, so let's understand how to implement this type of question. So can I take, let's suppose we have these nums, right? If we have these nums, we'll convert into the binary, right? Means binary is what? Let's suppose we'll take the 3 bits since max is 7, right? Max value is 7. Okay, so we know that we know that 8 4 2 1, if we apply very first to 1, we'll get 0 0 1. For 2 we'll get 0 1 0. For 3 we'll get 1 1 and 0. Like that we'll go, and for 7 we'll get 1 1 1. From 1 2 3 and we'll go till 7, and we say that we will apply whatever we need that. Okay, so we want two numbers whose bitwise AND is 0, right? We need two numbers. Let's call if we observe 3, okay, and let's talk about the 4. Okay, for getting the 4, what we need 1 0 0, right? We can say for 3 we know that the value will be 0 1 1, and for 4 we will have 1 0 0. This is a very good example, that is I'm taking. So these 3 and 4 doesn't share any bits, means it doesn't share, it will share no bits, we can say. Okay, so if you do this one, it will give you 0, right? If you apply the AND, right? If you apply the AND, it will give 0 0 0, means it will always be 0, right? So we can say the product of these two is nothing but 12, right? So any pair that contains 1 let's suppose in the case of 7, right, it is impossible, since 7 has all bit set, right? It's all a bit set, right? Because it's all 1, right? So the best value here is 12, we can say. So the output is 12. Understand? But the question is how we are going to implement, right? So what we are going to do, we will use pointer, right? An array we have, right? We have to update the array. So we'll use the DP. Okay, very first. So what we will do, we'll use SOS DP, we can say. For this approach, we will use 3 bits, right? From 0 to 7, as we know that, and we'll compute the best max. Okay, so this best max we have to compute first, and the best max is nothing but the largest number in the nums whose exact bit mask is nothing but is a mask. Understand? So for these nums we have to find the best mask, and the best mask should be mask, we can say. Okay, so let's suppose for the mask 1 to 7, right? If we'll take the for the mask, if mask from 1 to 7, we'll say what is best. Best is always 0. Can we say that? So if we want to find the mask, how we are going to find? Let's understand. So if I want a mask, okay, let's suppose 0, 1, 2, 3, 4, 5, 6, and 7. If I want the best, at 0 we'll say 0, at 1 we'll take 1, at 2 like that. We'll take all the elements initially. Now we have to, very first we need to do that, means we have to find, we have to compute the best mask, best at mask, we can say best at mask, and we say that we have to build. Then what we need to do, we have to build the DP at mask. So DP at mask, so that let's suppose if we want the DP at mask, right, it should be have the maximum best mask. Okay, for all the sub mask, right? Sub mask, if we'll talk about, sorry, sub mask is sub mask should be the less than equal to mask, we can say, right? We can say, so we can say it should be the, it should be in the mask. Okay, so we'll say how we are going to find that. Let's understand. So if we'll take a loop, right, we'll take I equal to, let's suppose we'll start from 0 to best minus 1, right? Can we say that? So for all mask we have to take 0 to what? It should go to the bit we have to take, left bit we can take, right? Left bit. Okay, and it should be minus 1. From here to here we have to go for all the mask. Are you understanding? Means we want to build the DP mask, and so the DP mask is nothing but what? The maximum of the best mask, right? Best sub mask, we can say best of sub mask. Okay, so and for that we will find the, for the 1 4, it will start I from 0 to best minus 1 will go, and for the mask it should go from 0 to 1 left shift bit we will go with the minus 1, right? So if the mask has, we can say bit I is set, at that time we'll do the bit mask equal to max. Will find max of what? The DP mask, as I told you, and its sub mask, we can say, and that is nothing but DP at mask. We'll take the operator and we'll use I, left shift will take. Okay, so in this case let's suppose the we'll talk about the particular example. DP remains equal to the best for all the iteration, and so in the DP we'll say 0 1 2 3 4 5 6 7. Okay, so now in the third step what we need to do is we will use for each mask we have to set best mask should not equal to 0. So for each mask that has a number, and before that number we can say bit mask is not equal to 0. So we'll check the best possible partner. Let's call, we'll take full is equal to 1 left shift, we can say b minus 1 is nothing but 7, right? And what is the partner here will be there? So we'll get the partner at full, and we'll take the bitwise operator and we'll say mask. Okay, so this is nothing but the best number whose mask is subset of the complement, right? That is nothing but the disjoint, right? So subset of complement is nothing but disjoint, we can say that, right? So for example, if we evaluate, let's suppose for the mask equal to 1, let's call 0 0, right? For no 0 0 1, it will be correct, right? So, and for this, the partner is what? We'll say DP at 1 1 0, and so DP at 1 1 0 is nothing but 6, and we'll say 6. Okay, so we can, it will say the product is nothing but 6. Similarly, for 0 1 0, we'll calculate this, it will come what? You have to take DP at 5, right? And this will give you 5, and if you find the product, it will give you 10. Similarly, we'll find another things. Let's call 0 1 1. If you find the mask at 3 is nothing but this one, right? So the partner will become what? DP at 100, and this will give you DP at 4. It will give you 4, and so the product will become what? Is 12. I think this is the best answer. It was coming. And similarly, we'll find the mask at 4. We'll find the partner. There will be some value. It will give you 12 again, right? Like that we have to find. So the mask will give 12. Like that we have to find. Let's understand the code. And then we'll find, once you find the DP mask, we'll find the values.